Hello, my name is Andrew Smith. I'm the Director of Technical Outreach at Power Integrations. Today we're going to talk about triumphing over the challenges of increased power delivery. So there is a market demand for more power, lower standby and higher efficiency. What we mean by that, we're trying to support an increased feature set. That means more power at low voltage for the microprocessors, which need to offer more functions to users. We want to get higher efficiency because of the increasing requirements of standards, but also it means we can eliminate heat sinks, which is really good for increasing the robustness of the power system in an appliance application, for example. We also want to support mains networks around the world. One of the things that we see is high variability in the supply voltage in a lot of applications, and that requires a very robust input power stage. Our link switch TN2 provides a simple buck conversion approach to achieve some of these capabilities. What we're looking for is a very simple design, very low no-load consumption, and the ability to support a wide input voltage range based on the MOSFET rating of the power device. We've just increased the capability of this product family to actually deliver more output power for those more feature-rich applications we described before. The nice thing about this technology is it gives high efficiency. We can get to 84 or 85% efficiency, and that efficiency is good even at very light load. And that's important when standby performance is becoming increasingly important. Also, regulation is excellent for these kind of applications. For higher power applications, we use the InnoSwitch 3TN. The nice thing about this product family is while it not only increases efficiency, it reduces no load, and we can effectively say zero no load consumption because it's less than 5 milliwatts input at no load. We are 87% full load efficient, and we even deliver 75% efficiency down at 10% load. And that's very good for standby applications where the microprocessor is still drawing power and you may have a limited input budget. We also are able to minimize PCB area using flux link magneto-inductive communication, simple bill of material, and isolation is achieved without the need for optocouplers. Because we're using secondary side control, we have very accurate control of output voltage and current, typically achieving less than 3% regulation on the CV output for the main output. This product family will deliver up to 16 watts, and it's very efficient. Let's go ahead and compare that to what we could achieve with a buck converter like the device shown previously. What we're showing here is the efficiency of an InnoSwitch 3TN design, either at 85 VAC or 265 VAC, compared to a buck converter across the same voltage range. And we're comparing load across the bottom with the efficiency as a vertical axis. And what you see is that the InnoSwitch family is significantly higher, as much as 10 or 12% higher than a buck converter doing the same power level. Also, you'll notice that the InnoSwitch 3TN family has very flat efficiency across that load range. Also, because of the high efficiency, we can deliver significant output power even at very light load. And what we're showing here is the input voltage range against the output power for a given amount of load. So we can deliver 150 milliwatts output when the input is only 260 milliwatts. That's really good, and it's excellent for applications that require a limited input power budget. So let's now look about how reliable this product is in worldwide applications, and that'll take care of the third part of the requirements that we're seeing in the marketplace. So we have a choice of different switch technologies for input voltage functions, and what we tend to do is select the most appropriate wide bandgap or silicon technology to support the application. And we aim to make that seamless for the customer. And the way we do that is have either GaN, silicon, or silicon carbide. And that gives us a range of anywhere from 725 volt breakdown up to as much as 1700 volt for silicon carbide devices. This allows us to survive extremely energetic voltage transitions or line swells, which are common in some parts of the world. So we can see that things like repeated pulse test or single pulse tests will be survivable by our technology. Even line voltage swells, which can be very, very bad for silicon, can be supported very easily with either silicon carbide or GaN technology or high voltage silicon. So the InnoSwitch 3 provides a platform solution for many applications. The InnoSwitch 3 EP with SiC or PowerGaN provides a choice of input voltage range. And we're showing this in detail here. We've got a 725 volt or 900 volt silicon option, a 750 volt GaN, which is robust and highly efficient, or a 1700 volt silicon carbide for the highest voltage applications. The InnoSwitch 3 EP family, that does between 10 and 100 watts output, and we can actually achieve 90% efficiency with this family. Output regulation is excellent, and that's because we're using secondary side control and the flux link communication technique. This allows us to reduce component count, achieve better than plus or minus 5% CV and CC accuracy, and also reduce the need for heat sinks. There's no heat sinks required even at 100 watts with the InnoSwitch EP technology. So to summarize, the market is changing. We need more power for our 5-volt output in appliances. The displays, the Wi-Fi communication, relays, all sorts of different applications now draw more power than they have done in previous generations. We need high efficiency, especially with a 500 milliwatt limit to meet European ERP regulations. And we can see that the output current at low voltage will go over 1 amp. This is moving us away from buck converters and into flyback technologies, which are much more efficient when the current gets to this level. We can use synchronous rectification to increase efficiency when you're in flyback. You can get 6 or 7% improvement at light load, or 3 to 4% efficiency improvement at full load. And this helps us eliminate heat sinks, which again increases reliability. Our wide bandgap offering means that we can choose the best switching technology. We are agnostic about which switching technology we use. Silicon is still extremely valuable in many applications, but we can also go to silicon carbide or to GaN to provide the highest efficiency or the most robust performance or worldwide applications. To find out more, visit us on the web at power.com. Thank you very much.